All right, we will be talking about 5G versus radar altimeters. I'm Emma, I use she, her pronouns, and I'm a senior.
I'm Riley, I use any pronouns, and I'm a senior. Yeah, so we are dealing with adjacent interference. So here our incumbent is radar altimeters, which is 4.2 to 4.4 gigahertz, and the 5G is the entrant with 3.7 to 3.98 gigahertz. To give a little more background on radar altimeters, they are essentially highly accurate devices that are used on aircrafts. There's 2 or 3 for redundancy, and they're more precise than barometric altimeters. They send a signal to the ground, it bounces back, and they receive it so that they know their altitude. And this is used in low visibility and low altitude situations where the pilot might need more information about landing.
And 5G is the 5th generation standard for cellular broadband. It is higher speeds and lower latency than previous generations.
Yeah, so to go into more about the players, first on radar altimeters, we have the Federal Aviation Administration, the FAA, and Airlines for America, which is A4A. A4A is a lobby group that consists of the major airlines, and essentially they have raised safety concerns since 2008 and don't view the FAA and the FCC as properly mitigating these safety interference, these safety issues. One of the biggest things is they believe that they're still going to have operational disruptions, such as 1.59 billion in disruption cost to passengers. And here's some other stakeholders. We also noted this report that a lot of the stakeholders have referenced. However, mobile carriers have called this report into question as skewing the data.
Right, on the 5G side, you can see that the 5G services market is pretty large, at least in the last data of 2021. The biggest players are the providers of 5G, so that's Verizon and AT&T, and we'll see them coming up a lot as the ones who are lobbying the most for the existence of 5G. We also have the CTIA, which is the Cellular Telecommunications Industry Association, which represents the mobile wireless industry and lobbies for them. On the right, we can see an op-ed that they released that is targeting one of the big reports claiming interference and claiming that it is filled with bad science and bad engineering. So as you can see, both sides are basically trying to discredit each other. So now the issue timeline. In 2018, as we said, was when the A4A first raised concerns about interference. In 2021, the FCC granted 5G its existence, essentially. Later in 2021, the A4A urged stall of 5G deployment, and it was delayed for about a month. The other important thing that happened then was that the mobile wireless industry self-imposed voluntary limits that would help mitigate interference just sort of in the meantime while things were figured out. In 2022, those voluntary limits were extended, but they're set to expire in 2023. And now for some interference geometry. Here we would like to credit Nick Laneman, who helped us find this IEEE paper, which modeled some interference scenarios. We have sort of condensed these models down for you. Here we can see a radar altimeter antenna up in the air on an airplane and a base station. This is mapping the interference received by the altimeter antenna from the base station. And this interference is dependent on the maximum power of the base station, the gains of both antennas, and the free space path loss between the two.
Yeah, and we also were mapping the interference to the user equipment from the altimeter. User equipment here is mobile devices and computers. And now to our proposed coexistence solutions. So on the mobile carrier side, we have some of the things we've talked about before, such as delaying deployments, voluntary limits, and as well, there's buffer zones around airports. In the airline solutions, the major thing is they've noted these kind of lowest performing radar altimeters and are requiring them to add filters or be upgraded. And to go into more about that, the FCC claims that the 220 megahertz guard band should offer all due protection. However, they have noted that radar altimeters may have originally ignored these spectrum limits and been transmitting far outside of their band. So now manufacturers are required to be adding these filters and upgrading their radar altimeters, and first kits are currently being installed. The FAA is requiring airlines to upgrade them for full operations by July 2023, which is also when we have noted that voluntary limits expire. And one example of this is free flight. So free flight, a number of their technologies under NDA, but essentially they use internal RF filtering and DSP technology to mitigate this interference. And one thing they've noted is that a better interference tolerance means that the protection radius can be smaller. And so here they have found that their new technology does have a smaller protection radius, which means that they don't have to deal with these kind of buffer zones and interference issues in the same way. And since August, these radar altimeters have been cleared by the regulations they need to be.
On the mobile wireless side, a bit about the voluntary delays and limits. So one of the voluntary limits that was imposed was buffer zones in like 2021 around airports. The other thing that we noted was reduced power spectral density of LTE emissions. So from this letter from Verizon and AT&T to the FCC, we can see that they agreed to a power spectral density limit of 62 dBm per megahertz for this sort of voluntary limit time.
Yeah, and finally, we wanted to go to our proposed solution, which is in line with what the industry is currently doing, which is essentially for manufacturers to keep rolling out these filters and upgraded radar altimeters to allow both players to have full power with their systems. In the short term, it's still helpful for mobile carriers to have these voluntary limits and delays. And specifically for this slide, we wanted to credit Ken Baker, who is the retired chief engineer for the Wireless Bureau within the FCC, for giving us a paper on voluntary limits and bringing us to this solution. Thank you.